All right, so we're going to go ahead and get started. So today our objective is to talk about the negative exponent law. You are going to be able to use it in order to simplify expressions so that when you have your answer will be in positive exponent form and there will be no negative in your answer. So let's see what that looks like. So if you look, they give us a to the power of negative n. So when you have a negative exponent, you have to take the reciprocal of the base and the exponent. Always get rid of the negative exponents in an expression. So how is this done? We have a to the power of n. We know that every whole number is over an assumed 1. So, because it's over 1, in order to take that a to the negative n, we need to move it to the bottom in order to flip the sign of the exponent. So you would take that a to the n and you would move it to the bottom. So you would get 1 over a to the positive n. Let's look at another example. If you look, we have x to the negative 2. In order to turn that exponent into negative again, this is over an assumed 1, and you would flip it. So x to the negative 2 over 1, the 1 moves to the top, and you have x to the positive 2. The sign switches. So what would happen if when I move a negative exponent to the bottom, what happens if I've already got one there? Well, we have, in this second example, we have 4 to the negative 3 over 4. And let me move this, telling us we're sharing our screen. We know, we learned with our exponent rules that we've already covered, that we know every number is to an assumed 1. So if there's not one there, there's a 1 there. So in order to make this 4 to the negative 3 a positive, I have to move that to the bottom. Well, when I move that to the bottom, I'm going to be left with 1 over 4 to the 3 times 4 to the 1, which they've got up here. I just wanted to show you that side piece where there was an assumed 1 there because they didn't put it in until they already did the steps. So I'm left with 1 over 4 to the 3 times 4 to the 1. And then we just follow our product rule that says when they have the matching base, you keep that matching base and add the exponents. So you'd be left with 1 over 4 to the power of 4, which equals 1 over 256. So let's look at a couple of examples. I've got some easy ones, and then we're going to do a couple more in-depth ones. So we know x over to the negative 5 is over an assumed 1. In order to change that sign, we need to flip it. So x to the negative 5, that x to the 5 moves to the bottom, and when you move it to the bottom, it becomes positive and goes under 1. So what if that negative sign is the bottom? We are still just going to flip it, and the act of moving it from the bottom to the top will flip the sign. So if I have 1 over k to the negative 7, that k to the negative 7 moves to the top and loses that negative sign and becomes a positive, and that 1 goes to the bottom, and you can drop it because we know all whole numbers are over that assumed 1. So you can just say that it is k to the 7. All right, and then this next example, we have x to the 3 and y to the 9. What I want you to see here is that when I flip it, that x to the 3 is going to stay at the top. Because if I moved it to the bottom, it would go from a positive to a negative. When we're switching from top to bottom or bottom to top, the sign changes. So we can only move the ones that we want the exponent sign to change. So when I have x to the 3, y to the 9, all of this is over an assumed 1. But this y to the negative 9 is the only sign I want to change. So that is the only part that is going to move to the bottom. So I would leave the x to the positive 3 up top and put it over y to the positive 9. So the act of changing it, moving it from the top to the bottom or the bottom to the top, as we saw in these couple of examples, changed the sign of that exponent. All right. So we are not always going to see just switch the sign. What if we had to go ahead and divide or multiply? So if we look at this first one, I have to divide. I know our quotient rule states that we are going to take our base, keep our base the same, we're going to say top minus bottom. And I know x to the negative 7 minus 3 become plus and negative, and I would be left with x to the negative 10. But as we were saying, that's a 10, not a 16. As I was saying, in order to make that negative a positive, we have to do one more step because our answers need to be in a positive exponent form. X to the negative 10 is over a positive 1. And in order to make that answer in positive, we would need to move it to the bottom. So we would be left with 1 over x to the positive 10. Moving it to the bottom makes it positive. All right, again, we're going to do the same process as our multiplication, our product rule. So we have x to the negative 3 times x to the 2. We're going to keep the matching bases and add the exponent. So I have x to the negative 3 plus 2. And then I have y to the 2 and y to the negative 4. So y to the 2 plus negative 4. Well, so our x, we know negative 3 and positive 2 is going to leave us with x to the negative 1. And y, we know positive 2 and negative 4 is going to give me y to the negative 2. And our last step, we have two negatives up top. In order to change the sign, we need to either move them. We need to switch them from top to bottom or bottom to top. In this case, they're at the top, so we're going to move them to the bottom. So we're going to switch that, and we're going to have 1 over x to the 1, y2. And if we wanted to go ahead and drop that 1, we could. We could just say it's 1 over xy squared. All right, and then I have two more examples. All right, so I have this next one again. We're going to divide like regular. So I have 6b to the negative 11 over a to the negative 13. So I'm going to keep that 6 where it is, and it's not going to change. And we're going to switch our negatives. So that negative up top would go to the bottom to switch its sign, so b to the 11. And then negative at the bottom would move to the top to switch its sign, so a to the 13. So the process of moving this to the bottom and the process of moving this to the top is what changes its sign. If we don't want to change the sign, we're leaving it where it was, which is why this 6 stayed where it was. All right, I got one more example for you. We have 2m to the power of 3. So, like we did before, we're going to do our division like regular. This 2 is going to stay the same because it's 2 over 1. There's an assumed 1 here. That's the invisible math of it. So we know 2 divided by 1 is just 2. And we know that with our division or our quotient rule, we know that it's going to be m to the top minus bottom. And 2 to the 3 minus 4 is plus and negative. So 3 plus negative 4 is going to leave us with 2m to the negative 1. And our last step, we cannot leave negatives in our answer. We're going to need to move that m to the negative 1 from the top to the bottom so it can be a positive. So it'll be 2 over m to the 1 or just m because that 1 is assumed. All right? And then, so our learning objective was to know what the negative exponent law is. What it states is that we cannot leave our answers in negative form. So when we are done doing multiplication or our division or whichever operation we are doing, we need to use the negative exponent law to simplify our answer. In order to do that, we would either take our negative exponent if it's on the top and move it to the bottom to switch the sign of the exponent, or you would move it from the bottom to the top in order to switch the sign of that exponent. All right, so you can go ahead. There is an assignment on this on Schoology. Please, if you have questions, come to our small group. Otherwise, you can go ahead and get started on this work on Schoology. Thank you. Have a great day.